Okay, today we'll talk about multiplying polynomials and factoring polynomials, which is the opposite of multiplying. And we're going to start off with the distributive law. The distributive law says that if you have a number out on the outside and two terms on the inside, we can multiply a to both of those terms. We distribute the a. So it becomes a times b is ab, and then a times c, the plus, it's plus the second term plus ac. So that's just one way of multiplying if you can't add these two. But let's look at an example with numbers so you can see that it's true. So just if I have 3 times 4 minus 7, so it even works for plus or minus, it doesn't matter what sign it is. So one way to do this without distributing, because we do know how to add this, is this becomes 3, 4 minus 7 is minus 3, and then we multiply. So this is PEMDAS, you do parentheses first, and then minus 3 times minus 3 is minus 9. So the distributive law that I just showed you says I can also distribute that 3 and get the same answer. So 3 times 4 is 12, and then 3 times a minus 7, and it has to be adding or subtracting the next term, is minus 21. And then what's 12 minus 21? Take the difference because the different signs, it's negative. The difference is negative 9. So we get the same thing. Now, my first example with multiplying, though, doesn't actually involve the distributive law. I just think it's a good thing to see when you distribute and when you don't. So it's 10a to the third times 5a squared. So remember, it says to multiply these. The rule is to multiply these, but it doesn't say to distribute, because you only distribute when you have a plus inside one of the parentheses. Okay, and we don't have that here. So we can just multiply the coefficients. 10 times 5 is 50, and then the a's get multiplied, same bases. It's a to the third times a squared, a to the third times a squared, which means we have 3 of these, a times a times a, 2 of those, a times a. Remember, we add the exponent, we don't multiply those. Okay, so we get 50a to the fifth. So no distributing there because there's no plus or minus to distribute. So my next example will be 2x times x plus 3, and we can distribute this. So whatever's in the front, we don't just distribute the x, we distribute the whole term that's in front, as long as there's no plus or minus between those two. It's 2x times x is 2x squared. Remember, you're adding those exponents. And then 2x times 3 is plus 6x. And those are not like terms, so we are done there. Okay, so our next example, we're going to take this a step further and have a binomial, 2 terms is a binomial, times another binomial. And we can distribute this exactly the same way we did. I'll show you how that works, but then I'll be doing it a different way. So this x plus 3, the whole thing can be multiplied to that x. So you can say x times x plus 3. And then the whole x plus 3 can distribute it to that 2. So plus 2 times x plus 3. And then we can continue with this. We can now multiply x times x plus 3, distribute it, is x squared plus 3x. And then continuing, I distribute the 2 plus 2x plus 6. And then we can see our two middle terms are the same. We can add them. So that's 5x plus 6, which is our answer. Now, the way I prefer to do this problem, I don't like to distribute two terms. It's just distribute, it's called the FOIL method, if you remember that. Same problem, but I'm just going to look at it a different way. You can take this x and distribute it to both of those terms, and then take the plus 3 and distribute it to both of those terms. And that is the FOIL method, because it's the first to the first. X times x is x squared. X times, that's called the outer, those are my outer terms, plus 2x. But don't remember FOIL as much as distributing. And then this 3 goes to both of those terms too. And then plus 3x, and then plus 3 times plus 2 is plus 6. And here we get the same thing. Middle terms add up. And what we're essentially seeing is two binomials, when you multiply it, you usually get a trinomial. Sometimes you'll get a binomial, which we'll look at that formula when we get there. Back up one example. This example, when you use the distribution rule, is if we go backwards, that's going to be common factoring, okay? In these two terms, when we factor, we have a 2 and an x in common. You write it, and then you got to figure out what's left. So that's why I wanted to put these two topics together, so you can directly see how learning multiplying applies to learning how to factor. Before we go on to factoring, though, I do want us to do one more example. And that example is x minus 3 squared. Okay, this is our biggest number one mistake in any algebra class, and even in calculus. This mistake happens a lot. You don't just square the first term and subtract the square of the second term. Okay, the base is x minus 3. That has to be written out twice. That exponent says to write your base out twice. So it's x minus 3 times x minus 3. You write the base out twice, and then now you can see you need to FOIL, because we don't write it out as x minus 3 and x plus 3. That's not, you write the same base out twice. So it's x times x is x squared. X times minus 3 is minus 3x. And then you distribute this minus 3. Minus 3 times x is minus 3x. And then minus 3 times minus 3 is plus 9. And we add our middle terms. You always get double your middle term when you do these perfect square trinomials. And you see we get a trinomial. Okay? So don't forget, you can never just distribute across a plus or a minus, ever. Now I'm just going to go over all the rules and the formulas, and then we will do some examples mixing up which ones to use. So my first type of factoring that you always want to look for first, this could be applied for any number of terms. If you have 2 terms, 3 terms, 4 terms, you want to look for this first, and it's called common factors. And again, what you have here is if you have AB plus AC, you see we have an A in common to both terms. You write out that common factor, and then you put a parenthesis there and say A times what is my first term? Well, clearly A times B. This is a plus, this is a plus, and you pull out that A. You're pulling out that A. What's left is the C, because you're kind of like dividing it. And you can see, remember just a couple minutes ago, this is the distributive law. Okay, it's factoring out the common factor. When you have 2 terms, in a way it's just a bunch of formulas you won't want to memorize. But there is rhyme and reason for each of them, and especially the first one. The 2 terms, the first formula is difference of squares. If you have a perfect squared minus difference, a perfect squared, difference of squares. Well, this is very similar to trinomial factoring because it gets factored into 2 binomials. Okay, well, we just don't have a middle term. So what we have is, if we have our first times our first times our first, you get a squared. A times a is a squared. And your last term, b squared is my last term. We break that up as b times b. B times b is b squared. If it's minus, we need 1 plus, 1 minus. And then we check our middle terms. So we know the first term works, this last term works, and then our check is plus BA. We rewrite plus AB, actually, alphabetical order. And then minus AB. And you can see they're the same term, but they're opposites, so they cancel, is 0. And we don't have a middle term, so this formula works quite well. A sum of squares cannot be factored. It's an irreducible polynomial. So the difference of cubes means you have a perfect cube minus a perfect cube. And it's similar, you know, a similar formula up here, except our first binomial, if this is a minus, this is a minus, is a minus b. The thing you have to remember is it's a binomial. It's not a binomial times a binomial. It's going to be a binomial times an irreducible, can't be factored, trinomial. Okay, 3 terms. So we actually have the ability to figure out the first and the last term, don't we? So what we're going to do is, this is a to the third. We know this is a. A times what is a to the third, because our first times our first should be our first term over here. Yeah, a squared. And then my last, I hop to my last, my b to the third. It's actually minus b to the third, so let's keep that in mind. So b, again, it has to be a b squared. B times b squared is b to the third. It's a minus times a plus will give me a minus, and that works out. But like I said, this is 3 terms, a trinomial here. So we need a middle term, and it just happens to be these two, AB. We multiply A times B. And if this is a minus, you only need, in this formula, 1 negative for all of them to cancel. So I'm going to make that a plus. And let's check this formula. How do we check it? Like any factoring that you do, you can always multiply it out to check. So a times a squared is a to the third. This is not FOIL, it's just distributing a to all 3 of these terms, and then b to all 3 of those terms, and then you'll have 6 terms to add together, not 4. So a times a squared is a to the third. A times plus ab, it's plus a squared b. And then a times my last term here is plus ab squared. And now we're going to distribute the minus b. Minus b times a squared. You could write minus ba squared, but you may not recognize that you have like terms, so I put it in alphabetical order. Minus a squared b is that first one. And then minus ab squared, alphabetical order. And then my last but not least, minus b to the third. This is plus a squared b minus a squared b. They're exact the same, but opposite, they cancel. And this is a b squared. Those cancel. And that's our difference of cubes. Now, we also have, unlike the squares, we also have a sum of cubes. Trinomial. I bet you we can figure it out. So a times a squared will give me my a to the third. My last is b to the third. B squared, I mean. You can always double check. B times b squared is b to the third. This is a plus, this is a plus, so this needs to be a plus. Now this is still ab. It's basically this first times your a times your b. And clearly this has to be a negative, otherwise nothing will cancel. And I'll let you guys pause it and check it yourself for practice multiplying if you like. Now 3 terms. Hopefully you've caught on to how I'm going to do this. I don't use any tricks to factoring, okay? I have 3 terms, and let me scooch up here and look at the example of a binomial times a binomial. I got a trinomial, so that's 3 terms right here. This is 3 terms. When you go backwards, it's going to be factored into 2 binomials. So knowing that is more than half the battle. And again, if you just multiply a whole bunch of them, you'll remember it. So that's what we're going to do. We're going to multiply it to 2 binomials. And the way we are going to figure it out, I call it a guess and check. Our guess, it's an educated guess though. My first times my first will be my first. And my last times my last will be my last. Okay, that's my guess. It's an educated guess because then we'll have our first and our last working out. And then my check is checking my inner and my outer and adding them and making sure that the bx works out. Of course, I'm not going to factor ax squared plus bx plus c, so we'll have to see with an example. Factor by grouping. Okay? So let's get started here. Let's do our first example. So this is the harder of the trinomial ones. I like to just jump into this because most people don't have trouble factoring it if this is a 1 in the front, especially if you're using this method that you learned in high school. So what I do, I know it's going to factor into 2 binomials. Okay, so we start off with the first term. The first term here and the first term here have to multiply to give me 3x squared. This times this is 3x squared. That x is going to be broken up. Well, the only way to break up 3 is 1 and 3, so we'll try 3x and x. Okay, so now the last term times the last term should be minus 8. Okay, there, we can try 1 and 8. I don't try 1 and 8 to start with. I'll try 4 and 2 or 2 and 4. Both of those are reasonable guesses. Let's try 4 and 2. It's a minus 8, and you're just guessing at this point, but I like to put it in there. I'll guess a plus and then a minus. And then if it's off by a negative, I'll switch those two. But so far what we have is 3x squared works. The minus 8 plus 4 times minus 2 is minus 8. That works. Now we need to check the middle terms. This is plus 4x, inner, and the outer 3x times minus 2 is minus 6x. That 4 and 6 add up to be 10, but these are opposites, remember. That's minus 2x. So, I mean, if you want to show your work by putting a big fat, don't erase, okay? Because in case it doesn't factor, you can write irreducible, but this one does. We got to try as many as we want to show our work. So let's try this again. 2 binomials, and we'll start with 3x and x again. But again, because these aren't the same, it's not the same if we put the 2 here and the 4 here. So if we put the 2 here and the 4 here, and then let's say we guess minus and a plus. Okay, again, so again, this 3x squared works, and the minus 2 and the plus 4 is minus 8. The first term and the last term, that's my educated guess. And then we got to check, again, always check. Minus 2x, that's plus 12x. When I add those, that's plus 10x. So close. We're just off by a negative. You go and switch your negatives. So here, if you want to, you can either rewrite it, or you can, I'll just rewrite it. So it's 3x plus 2, x minus 4, and we don't need to check it because I know if you just switch the negatives, we'll get the opposite, but let's just check it for your peace of mind. That's plus 2x, that's minus 12x, that adds to be minus 10x. Yes, now that works. I put a check mark there and box that answer. Okay? Difference of squares. So first times first, x is x squared, minus 16, 4 and 4, and it's minus, 1's a plus, 1's a minus. We can check plus 4x, minus 4x. They do cancel. There's no middle term, and that's our answer. Okay, how do we factor this one? It's 2 terms, but it's nothing special. We see here right away there's an a in common in both terms. So we do common factor first. So there's not just an a in common. You always look for the numbers too. 7 and 14, 7 divides into both of those. So we know there's a 7 in common. You're looking for your least common. And between an a to the third and the a, there's an a in common in both of those. And what's left? 7a times what is a to the 7a to the third? How about just an a squared? Remember 1 and 2 is 3. Minus, stays a minus. 7 times 2 is 14. You took out the a basically. What's left is a minus 2b. And a squared minus 2b, since that's the power of 1, that's not a perfect squared, it's not a perfect cube, we are done. That is my final answer. If it said multiply, I would distribute this, I would distribute the 5, and then we would be done. But it says factor, which, if you really think about it, this is 2 terms. It's this group plus this group. This is x times x plus y. So it's a binomial. And what we do see here also is x plus y and x plus y, it's in common to both. So that's my common factor. This is common factor, my factor of x plus y. And then you're factoring it out. Basically, x plus y times what is x times x plus y? Well, that would be x. X plus y, and this is a plus, times what will be 5 times x plus y. How about just a 5? That works. Again, look at x plus y times x. That's x plus y times x. And then that gets distributed x plus y times 5. Okay? So that's my answer. Okay, so we have 4 terms. 4 terms, I told you we do factor by grouping. Because we have 4 terms, guessing and checking is just not really going to work. So, factor by grouping. What I mentioned was you group the first 2, you group the second 2, and by grouping, I look at this, I just look at the first 2 terms and say, well, what's in common in just the first 2 terms between x to the third and 3x squared? We have an x squared in common, okay? And then what's left? X squared times x is x to the third. And then you're pulling out x squared, but that 3 is being left. Now, there's really no number in common with this x minus 3. Your goal, though, is like our last example, to try to get the same trinomial in common, okay? Since it's an x plus 3 and I have a minus x plus 3, and they're both negative, so maybe factor out a negative 1, okay? So negative 1 times a minus x is a plus x. You're just changing the sign of both. Minus 1 times what is minus 3? That would be plus 3. So you know it worked when you have a common binomial in both of the terms. So now it's just like the previous example. I have an x plus 3 in common to both of those groups. And I factor out an x plus 3, I'm left with an x squared. I factored out an x plus 3 minus 1. Okay? Like I said, here to here gives me this. X plus 3 minus that gives me this. And we're not quite done because we do have a perfect squared, x squared, and 1's a perfect squared. So this could be factored using difference of squares, x plus 1, x minus 1, and we got to bring down our last factor, and so that factored into 3 binomials. And again, if you just want a quick check, x times x is x to the third, that's my first one, plus 3 plus 1 minus 1 would be minus 3. And not that I'm checking everything, but it's a quick check to make sure at least the first and the last worked out, and it does. Okay, that's it, folks. If you like my video, you can subscribe.